Welcome to this explainer. Today we are doing something that is honestly just incredibly fun. We're taking pop culture's absolute greatest icon and putting him right under a real-world microscope. We're going to look at the Man of Steel himself, Superman, not just as a comic book myth, but as a genuinely fascinating scientific puzzle. From the intense astrophysics of his journey to Earth all the way to the bizarre biology of his super senses, we're diving into exactly what happens when science fiction meets actual rigorous science. So think about it. If the universe is truly infinite, then the possibilities for life are pretty much infinite, right? Let's treat Kal-El not as this unexplainable magic, but as a biological mystery that is just waiting to be solved. Is a being who absorbs sunlight for immense power and who literally defies gravity physically possible? Well, to answer that, we really have to look at where he came from. Okay, so Superman comes from Krypton, which is a planet orbiting a really harsh red sun, and its gravity is estimated to be somewhere between 5 to 10 times stronger than what we have here on Earth. Now, basic evolutionary biology tells us that any organism evolving in a high-gravity environment like that would absolutely have to develop incredibly dense bones, tightly packed muscle fibers, and just an ultra-dense molecular structure overall, merely to survive. If you take a species that has evolved for billions of years under those crushing, intense conditions and suddenly drop them onto our nice, low-gravity Earth, they would inherently seem super strong. It's actually a lot like how our own human astronauts can just effortlessly bounce around on the moon. But hold on, because pure gravity only gets us so far. Enter the square cube law. This is a real mathematical principle, which dictates that as any biological organism grows, its volume and its weight increase far, far faster than its surface area and proportionate strength. What does that mean for us? It means pure physical muscle density from a high-gravity world really only explains a tiny, tiny fraction of Superman's incalculable power. To lift entire buildings, he needs something way more potent than just dense bones. He literally needs to be the ultimate solar battery. His body has to metabolize Earth's yellow sun radiation. Now, not Earth, we already have organisms that use sunlight for direct energy, right? Plants do it all the time through photosynthesis, and even human skin synthesizes vitamin D. Superman's biology essentially does this same thing, but on a massive, almost nuclear scale. His near-unbreakable cellular bonds act like a battery, storing this energy to fuel his abilities. Though, to be fair, scientifically speaking, this completely challenges the law of conservation of energy, because the insane energy output required to, say, push a planet out of orbit would require him to continuously absorb star-level radiation without his body just completely overheating and exploding. Moving right along to Section 1, the physics of flight and telekinesis. Flight without wings is a massive, massive headache for physicists. Here on Earth, every flying organism or machine absolutely needs three things: lift, thrust, and an energy source. Birds use aerodynamic wings to displace air. Rockets use massive chemical propulsion. But Superman, he just kind of flies horizontally. He doesn't have aerodynamic wings for lift, and he certainly doesn't have a massive exhaust system for thrust. Plus, bending gravity naturally requires extreme space-time curvature, which we really only see from planetary-level mass. So traditional physics simply cannot explain a man just floating around in the sky. So the comics actually attempt to solve this physics nightmare through something called tactile telekinesis, or a bioelectric aura. Essentially, this is a solar-powered electromagnetic field that completely engulfs his body and literally anything he touches. Have you ever wondered how Superman can catch a falling jetliner by its nose without the massive tail end just completely snapping off from gravity? In reality, the plane would just buckle under its own weight. But this telekinetic aura evenly distributes the force across the entire object through just that single point of contact. And it also explains his flight. He consciously uses this invisible aura to manipulate the surrounding gravitational fields, allowing him to outright defy gravity and levitate. All right, next up is Section 2, the catching people problem. So the legendary astrophysicist Neil deGrasse Tyson summed this specific issue up perfectly. If you are falling off a building at terminal velocity and Superman flies up at super speed to catch you, his arms of steel are physically no different than the concrete pavement below. Hitting him would be exactly like hitting the ground. You would literally be a bug on a windshield. As Tyson put it, quite rescued, but quite squished. So quite dead. To truly save someone, Superman's physiology has to do way more than just intersect their fall. He has to perfectly match the trajectory and then use that bioelectric aura we just talked about to instantly absorb their momentum and all that kinetic energy the second he makes contact. He essentially has to act as a giant flying airbag. He stops the person in midair by safely absorbing the devastating impact that would have otherwise completely destroyed their body. Which brings us to Section 3, Super Senses, Breath, and Digestion. Let's look at his iconic freeze breath. Believe it or not, this actually aligns beautifully with a real thermodynamic principle called the Joule-Thomson effect. This effect dictates that when highly compressed air is rapidly pushed through a restricted opening, its overall temperature completely plummets. Superman uses his immense lung strength to supercompress a lung full of air, and by intentionally directing it out forcefully through tightly pursed lips, that high-velocity, high-pressure air rapidly cools into an Arctic blast. Pretty cool, right? Then there's his X-ray vision, which operates by perceiving background cosmic radiation bouncing off objects. Now, there is a very famous movie scene where he uses it to guess the color of Lois Lane's underwear. But here is the major scientific quirk with that. Real X-rays pass straight through soft clothing to show dense materials like bone, and they absolutely do not perceive color. So guessing pink underwear is scientifically bogus. Well, unless, as some astrophysicists point out, he has an incredibly advanced evolutionary trait where his eyes act kind of like the Chandra X-ray Observatory telescope in space. If he can detect and mix both hard and soft X-rays in different bands, his alien brain could theoretically composite them to create a full three-color image. And this brings us to a surprisingly fascinating and honestly pretty humorous biological debate. What exactly happens when a superpowered alien digests a Tuesday night taco? So if normal human digestion creates anaerobic gases like highly flammable methane and hydrogen sulfide, superdigestion would theoretically create, well, supermethane. As Neil deGrasse Tyson hilariously hypothesized, he could literally let one rip, ignite it with his heat vision, and instantly have a devastating rearguard flamethrower. No villain could ever sneak up behind him. But the counterargument here is equally grounded in real biology. Kal-El arrived on Earth as an infant, basically a pre-colonoscopy baby. He had not yet developed Kryptonian gut flora. Therefore, any gut bacteria he has was acquired right here on Earth, which means his digestion might just be painfully, completely, ordinarily human. Let's jump to Section 4, the interstellar journey. Did you know DC Comics once contacted Neil deGrasse Tyson to help them make sense of Superman's actual timeline? The problem was this. Kal-El leaves Krypton as an infant, arrives on Earth unaged, and then as a 20-something adult, he looks through a telescope to watch the light from Krypton's destruction finally reach Earth. Tyson quickly pointed out a huge issue. If his ship traveled at the speed of light, relativity means he wouldn't age, sure, but the light beams of the planet's explosion would literally travel right alongside his ship. He couldn't arrive, wait 27 years, and then see the explosion later. The only scientific way this timeline actually works is if the infant's chip instantly bypassed normal space entirely through a wormhole. Because of that awesome conversation, DC asked Tyson to officially locate a real-world star to serve as Krypton's sun. He found a red dwarf about 27 light-years away. But it gets even better. It was located in the constellation Corvus. And what is Corvus? It translates from Latin to the crow. And incredibly, no joke, the mascot for Clark Kent's Smallville High School has always been the crows. This absolutely beautiful alignment of real-world astronomy and comic lore became official canon, leading to a comic panel where Superman uses a real planetarium telescope to finally witness his homeworld's end, an event that actually brought the Man of Steel to tears. Finally, let's wrap up with Section 5, Science Meets Comic Fiction. You see, evolution is not about achieving perfection or optimization. It is simply about adaptation. Life's ultimate driving goal is just to survive. Nature designed Kryptonian biology not to be unstoppable gods, but to merely survive an incredibly hostile, high-gravity world bathed in harsh red radiation. So the crucial point here is that when you view Superman through the lens of extreme adaptation, his dense molecular structure and his solar-absorbing cells become a deeply fascinating cosmic thought experiment, rather than just pure comic book fantasy. And that leaves us with this final thought. If life and evolution are driven entirely by adapting to the most extreme conditions imaginable, and the universe is vast beyond our absolute comprehension, what infinite, extraordinary possibilities for life are actually out there, right now, just waiting to be discovered? Thank you so much for joining me on this explainer. Keep wondering, keep looking up, and I will see you next time.